Good morning, everybody. Today is Tuesday, September 6th, 2022. I am man looking at rain clouds. It is quite the rainy day here in Philadelphia. But yeah, we're back and we're going to do some more Elixir Exercism. Today, I believe we're going to review the concept of access behavior. So let's get right into it. So, Elixir uses code behaviors. Elixir uses code behaviors to provide common generic interfaces while facilitating specific implementations for each module, which implements it. One such common example is the access behavior. The access behavior provides a common interface for retrieving data from a key-based data structure. The access behavior is implemented for maps and keyword list, but let's look at its use for maps to get a feel for it. Access behavior specifies that when you have a map, you may follow it with square brackets and then use the key to retrieve the value associated with that key. So in this example, if you have a map with the key of the word key, atom key, and the value, my value as a string, and you got my map, your map, obtain the value using the access behavior my map. You can use key atom, and that'll work. You can use your map. Key is nil, and then key is string is your value. So, yeah. If the key does not exist in the data structure, then nil is returned. This can be a source of unintended behavior because it does not raise an error. Note that nil itself implements the access behavior, and you always return nil for any key. Oh, that's interesting. That is interesting. I'm going to try that out real quick. IEX, let's say, I don't know, foo equals nil. And then we'll say foo bar. That returns nil. Interesting. Okay. Alright, cool. So today we're gonna work on basketball website. You are working with a web development team to maintain a website for a local basketball team. The web development team is less familiar with Elixir and is asking for a function to be able to extract data from a series of nested maps to facilitate rapid development. Okay. So let's go and download our exercise. And we'll open it in VS Code. Let's show you we got website there. I want to turn this off. I'm tired of seeing it. All extension? No. I'll allow multiple, but not Docker. I don't want Docker just yet. No, I don't want that down there. I want that over there, and I want something over here. So put the test file over here, and we'll put the README down here, and we'll close that, and we'll collapse that. Oh, we got a lot of describes. Okay. Oh, and the other thing you'll notice too is that the spelling, this is intentional. Like in American spelling, you would probably say IOR, but it is IOURS behaviors. So, alright. Implement extract from path, function to take two arguments, data, a nested map structure with data about the basketball team, path, a string consisting of period delimited keys to obtain the value associated with the last key. So for example, data comes in as team mascot, animal actor, and then you're supposed to implement that. Okay. Let me check something. Access module. Yeah, that's how like I know to do like kind of like a nested structure. Put in, update in. Yeah, I used all those before. Key element all. I don't know. Let's see. So like if you're given, I mean, that I understand. Animal. Team mascot dot colors. How would you? I am immediately blocked. I'm trying to think. So, like, if you're given team mascot dot animal, like, I mean, the way that looks is like, you know, data, and then you'd have like the element, like element 1, element 2. But I don't know. And you could put a variable in there. So, like, if you knew, you know, if you knew it was, you know, path 1, path 2. But that's a little weird. What's number 2? Refactor using included functions. Your coworker reviewing the code tells you about the kernel module function which does something very similar. Yeah, like get in path. Implement get in path uses arguments expected. Okay. Your coworker reviewing your code tells you about a kernel module function which does something very similar, but they don't tell you what it is. That's funny. Yeah, I mean, get in. Yeah, I mean, that's what I've used before. How do they want you? I'm very curious how they expected you to implement this without get in. Do not use any map or kernel module functions for working with the nested map date structure. I mean, like, you could solve that by, like, breaking this out, like, splitting this string on dot, and then, you know, doing, like, a for loop or something to, like, pull it out. I mean, like, you could really come up with some weird solutions. That would be, well, I guess they want you to do both. Implement extract from path function that takes 2 arguments. Implement get in path. Okay, so we do have to build both of these. Okay. So, I mean, you could, path items equals path string dot split, and we're gonna split path on period, and then that'll give us a collection of items, and then you could just use recursion. You could just use recursion, and then, like, so if path items, let's see here, if path items length is greater than 2, do else. Maybe you wouldn't need to do that. Maybe you could just do, I mean, for each one you need to, I'm making this way harder than it needs to be. Alright, let's just do it as 2, and then we'll work on this. So, like, for this test, this very first test, run a cursor. like that's gonna fail. So we're gonna split. So assert on team name. Well, I mean, to make that work, you would just say, data path, and that'll pass. But then the next one, second layer, this will not work. And the reason it doesn't work is because you're looking for coach.firstname and you don't have that. So what you'd want to do is you want to pull path items, and you want to do that, and then for the list.first path item, yeah, this is where like if length of path items is more than 1, do else. So if it's only 1, then you would get the first path item and then that'll return it. Otherwise, you want to call, you want to get, the new data. Can you do that? Yeah, you get the first element. And then you'd get the new path. And that would just be you'd remove the head and then just grab path items. Yeah, you need to use it. And then you'd call extract from path and you'd pass in new data, new path. That's just a dialyzer. Yeah. Following arguments were sent to the thing. Just first name. Oh. You don't need to, there's no period there, so instead of using length to determine, string dot contains path period. If it does, then we would break it into that. Otherwise, we would just return data path. Right? If string, first name. List that first. If length of path is greater than 1 and first argument is not a list. I'm gonna put type spec just because already I'm like not keeping up on the fact that like this is a map and then this is a string. Oh, and it returns any. Yeah, I don't know if I can really say what it returns. What don't you like about that? Invalid type. Success typing is nil. I mean, I guess it could be nil or nil. I'm not gonna worry about that. Let's see. So this is gonna come in as a map. That's gonna be a string. So the first thing I want to say is oh, if I call this, I need to like join them. List join to string. Converts a list of integer converts a list of integer operating code points into a or strings into a string. That should work. List.toString. List of integers represent code points. List or strings into a string. No, but I want like I want to join them. Is it join? It's enum path. Join list. Let's see. Join. I mean, you can join enum. We haven't done the enum module yet, though, so like we're not really supposed to use it. Yeah, enum is not till later. Yeah, we didn't do enum yet. I mean, we're close. But technically, we're not really supposed to use enum. What does enum use internally? I ain't gonna touch that. You could fold it. No, folding would make it a single value. Which reduces the given list from left with a function requires an accumulator can be any value. I guess you could use fold. List fold. Yeah, because that's like you need new path string. And so you would accept the path, new path. You'd have an accumulator, which would be an empty string. And then you take X in the accumulator and you would say, I want to, this is so clunky. Because you can't just put a dot at the end of it, because then you'd have a dot at the tail. Oh man, that is so dumb. I'm gonna do it just because, and then I'll say, oh geez, I'm gonna say new path string equals, like where's the first? No, man, that's stupid. Oh, that's so bad. This is, I am totally overthinking it. I don't think they would give you, like, the first job is supposed to be a really simple thing. Like, you know, like the whole point is like they've just taught you this, and then you're just supposed to just go and like do it, and it should be like step one should be like this really simple exercise. The other way to approach this, we'll just put this down here. Keep it, but oh my. The other way to approach this would be to pattern match, like use binary pattern matches to get the first element of the path. And then similarly, like, you know, if so you'd still have to do like if string contains path, like if it contains a period, then we'd want to, you know, break the path and do some recursion. If there is no period, then we can just assume, you know, we're returning, you know, data path. But if there is a thing, then we would need to get like the target key, and the way we could do that, how do you do? Forgot a T in pattern matching. All right, let me just think this. Let me write this out loud. So what we want to do is we want to pull out the first key, and then we want to pull out the data associated with the first key, And then we want to like assemble new path string, and then you want to you know, call ourselves. I mean, that's basically what we're trying to do here. So one way to do this is, of course, string split path comma period. So this is going to return a list, and the first element is going to be our target key, and then the remaining tail of the list is going to be remaining path as list. So then we'll say target data equals data target key. Then we need to assemble our new path string. So how do you assemble? What is the opposite of split? What is the opposite of split? It's probably part of the list module, because I mean, that's what we have. I mean, fold, flatten. Char list. I mean, you could do it. You could make a char list and then, you know, make the char list into a string. Couldn't you? Easily? Yeah. List to string. Convert a list of integers representing code points list of strings into a string. To be printed on a list must be empty or only contain the following elements. This is I'm missing something simple here. I mean, given that we have the path here, you know, you could do string like removal. Like with a prefix or something. Replace prefix. New path string. So we're gonna take the path. Hello world. Yeah. We're gonna take the path. We're gonna take the target key. and we're going to replace it with nothing. And that'll be the other one. And then we're going to call ourselves. So extract from path. And this will be the target data and the new path string. Remaining path as list. We didn't use, so we can just remove that. Let's see if this works. I think it's lost in itself. Let's see this again. 17. Yeah. Okay. Let's inspect ourselves. Target key label target key, and then we'll do this target data, new path string, and then we'll see what this thing is doing here. So target key was empty. So if path contains, what's path? Let's print these out first. Data, path. Data is nil. Path is, what the hell is data when it started? Why would data be nil? Team data coach dot. First name. Yeah, my console only goes a little further away. I thought there was a sleep function. Process.sleep, yeah. Alright, let's see. Alright, so this opened up. So this started up, you got data, big map, coach, first name, so forth. So the path given in was coach.first name, the target key was coach, the target data was that looks good. The new path string is dot first name, that looks very questionable. Alright, I think that's what we need to fix. So string.split. So we need to remove not just target key, but target key period, and that should all right, that looks good. Third layer, let's test third layer. We'll get rid of this process sleep, and we'll test third layer. Run a cursor. That looks okay. And we'll run fourth layer. That looks okay. And then we'll look at this one. That looks okay. And then getting path receives from. Should those have task? Yeah, these are all task ID too. Okay. All right. I'm gonna comment these out for now. And we'll get to work on the second part of this. Holy moly, this is a lot longer than I thought it would be. Number 2, refactoring using included functions. Your coworker reviewed your code and tells you about a kernel module function, which does something very similar to your implementation. Implement get and path using this kernel module. So the kernel module they are talking about, kernel is get in, and get in basically accepts a structured value and then a list which describes the path, which is exactly what we want. So data and then path. So path is still coming in as a string. Yeah. So we'll need to string dot split path on period, and that should work. So let's test. Let's test everything. Yeah, that all works. Okay. So let's delete our trash. Let's see if this solution looks good in a tight fashion. Spec. Can we keep that spec? Or no? Yeah, that looks good. That would be the same spec, right? At spec get in path. This would be a map, and this would be a string, and the return type is any or nil. I think it looks good. Alright, extract from path. So it takes in data in path. If the path contains a dot, we take out the target key. We grab our target data. We generate the new path string, and then we call ourselves using the target data and then the new path. Else, we just return data path using the accessor style. And then get in path just uses the real kernel module, which you would use every time. And that looks good. All right, so let us run test one more time. And let us submit. And let's see if the computer has anything bad to say to me. It looks good. Analysis and test. That looks good. Community solutions. Yeah, you see they used reduce enum. Like, I don't want to use enum because we haven't learned enum yet. That is like the challenge. That is like the most challenging part of some of these exercises that I would definitely use different things here. So, okay. So these people extract from path, do extract from path. So they're using a little bit of pattern matching in the function heads rather than the if statement, which is fine. A lot of people will prefer that over if statements. If statements are not super common in a lot of more standard Elixir code bases. Oh, this one created an extract value function. Value. Cool. Those look good. I think I'm pretty happy with our solution for now, though. I'm not going to change it to pattern matching. All right, I'm going to mark it as complete. I'm going to share my solution, and I have learned, quote unquote, access behavior. And that's the only exercise related to access behavior, and then that unlocks structs. So next time we have our choices of enums, binaries, and structs, and I don't know which one I want to do off the top of my head yet, but we'll figure that out tomorrow. For now, I want to thank you for suffering along with me and watching. If you have any questions or feedback, definitely let me know. Other than that, I'll see you next time. Bye-bye.